Hello and welcome back to MEARLADVISOR. Today, we're diving into a concept that forms the bedrock of rigorous data analysis in our field: maximum likelihood estimation. Now, I know that might sound like a complex statistical term, but stick with me. In the world of monitoring, evaluation, accountability, and learning, MEAL, our primary job is to find the true story hidden within our project data. We aim to move beyond gut feelings and anecdotes to evidence-based conclusions. Think of a typical project. We have an outcome we care about. Our dependent variable, let's say community literacy rates. We believe this outcome is influenced by a combination of interventions. Our independent variables, such as hours of tutoring, number of books distributed, and level of parent engagement. The central challenge we face is quantifying exactly how much each of these factors contributes to the result. This is where maximum likelihood estimation, MLE, becomes our most powerful ally. In essence, MLE is a sophisticated way of asking a very simple question. Given the actual results we observed in the field, what are the most probable values for our project's key parameters? It works by calculating the likelihood of seeing the exact data we collected under different possible scenarios for our model. The beauty of this method is that it often confirms our most intuitive approaches. For many standard project models, the complex calculations of MLE lead us directly to the same answer as the method of least squares. The process of finding the line that minimizes the squared differences between our predictions and the real-world outcomes. So, that sophisticated statistical theory ultimately validates a common-sense principle. The best model is the one that makes the observed data look the most probable, and the prediction error the smallest. But for us as moral professionals, the real value isn't just in the calculation, it's in the interpretation and application. Understanding the statistical properties of our estimates allows us to excel in our core functions. For accountability, we can create confidence intervals. Instead of reporting, our intervention increased incomes by $100, we can robustly state, we are 95% confident the true increase is between $85 and $115. This provides donors and stakeholders with defensible, transparent evidence of impact. For learning, we can test hypotheses rigorously. Is our new agricultural technique significantly better than the traditional one? The framework provided by MLE gives us the tools to answer that question with data, directly informing future project design and resource allocation. This foundational idea opens the door to an even more powerful toolbox: M-Estimators. This is a generalized approach where we estimate parameters by minimizing a custom function. The power lies in our choice of that function, allowing us to tailor our analysis to real-world data challenges. For instance, if we use the square of the error, we get standard least squares, which is great for clean, well-behaved data. However, project data is often messy. If we have a few extreme outliers, perhaps one project site that experienced a unique shock, we can use a robust estimator based on absolute values, which is less swayed by those unusual points and gives us a more reliable picture of the typical project impact. We can even model quantiles to understand if our intervention had a different effect on the poorest beneficiaries compared to the better-off ones. Let's make this concrete with a case study. Imagine you plot your project's results and see a clear trend, but then notice one or two highly influential data points. Perhaps one community had an exceptionally motivated leader. Using regression diagnostics inspired by these estimation principles, we can ask, is this single outlier driving our entire positive result? By applying robust methods, we can test the stability of our conclusions and ensure we are learning the true story of our project's performance, not being misled by anomalies. In conclusion, from the foundational logic of maximum likelihood to the flexible world of M-Estimators, these are not abstract mathematical concepts. They are essential superpowers for any serious MERL practitioner. They empower us to implement rigorous monitoring, conduct defensible evaluations, uphold true accountability, and generate meaningful learning. They are the tools that help us transition from saying "I think" to stating "I know" based on solid empirical evidence. If you found this exploration useful, please like and subscribe to MEARLADVISOR for more insights that bridge the gap between theory and practice. I'd love to hear from you in the comments. What is the biggest challenge you face when analyzing your project data?